Greetings from Dr. T. Sindil Murugan, Associate Professor and Head Department of Information Technology, Kakatiya Institute of Technology and Science, Varangal. In this video lecture, we are going to discuss about Radix art. In previous video lectures, we have discussed about bubble chart, selection chart, insertion chart, cell chart with the time complexity and space complexity of each and every algorithm. So especially what is Radix art, how it is working, how to write the code for Radix art, those things we will discuss in this video lecture. This is week 12, lecture 2, classroom discussion topic 35, that is CDT-35. The topic name is Radix art. So before starting the discussion of Radix art, we must know the outcome of this lecture. After completion of this lecture, students will be able to develop a C program to develop a Radix art program to sort the given n elements. Whatever numbers we will give, the program, the students have the capability to write the program to sort using the Radix method. So what is Radix art? Radix art algorithm is a non-comparative sorting algorithm in computer science. So normally, previously whatever algorithm we discussed, like bubble sort, selection sort, cell sort, insertion sort, those algorithms are comparison based algorithm. So it will compare the next value, based on that it will perform that. It is in place comparison algorithm, we are already known about it. So this Radix art is non-comparative sorting algorithm. It is not compared with the values. It avoids comparison by creating and categorizing the elements based on their radix. Okay. So radix means we can say digits normally. For example, 0, 100 is there, means this is the radix 0, radix 1, radix 10, radix 100. So like that we know that the digits, okay, ones place, 10th place, 100th place, 1000th place, 10,000 place. Like that we know that the digits value, no? So based on the radix, it will be work. For elements with more than one significant digits, it repeats the bucketing process for each digit while preserving the previous step ordering until all digits have been considered. Okay. So first we have to find which is the maximum number, because maximum number have the maximum digits. So we have to find which number is the maximum and how many digits it have. So that after finding that, we will start the Radix sort algorithm. So Radix sort and bucket sorts are almost equivalent. Okay, we have to create the bucket. We will keep that elements which is related to that bucket. Like that, it will go. But bucket sort will work from most significant digits to least significant digits. While Radix sort is capable of both direction, least significant digits and most significant digits also it will be considered. So what is Radix sort algorithm? How it is working? That we are going to discuss. Okay, Radix sort is a linear sorting algorithm. So how it is a linear sort algorithm? It will check one by one element. Accordingly, we will work it out. But we will, before going to that, we must know this time complexity of the Radix sort is order of n d. Here n is the number of and that means entire size of the array. So number of elements in the array. And d is number of digits in the largest number. I said no, that we will start from the highest number. So we must know which is the highest number. So how many digits of the highest number into size of the array. So it is based on that. This is the time complexity. It is not an in-place sorting algorithm because it's required extra space. So we have to create the bucket. That bucket we will keep the elements. For that we need extra spaces. That's why it is not in-place sorting algorithm. Radix sort is a stable sort because it's maintains the relative order of elements with equal values. Okay, so you just remember it's a stable one. A Radix sort algorithm may be slower than the other sorting algorithm like merge sort and quick sort if the operations are inefficient. When if it is the more number of elements are there, then it's have less number of elements, but some digits, some numbers have more digits, means then it is inefficient. So in this manner, it is slower than merge and quick sort. How it is working? So Radix sort algorithm works by ordering each digits from least significant to most significant. Okay. First, what we will do, we will take the number. Okay. So for example, 1, 100, 10,000. Like that, if we have the number, we have to sort it out. So what we will do, and which is the maximum number, we will take this maximum number. So before taking this maximum number, we will take the first digit. Okay, so this is a 0 digit, this is a 0 digit, this is a 0 digit, this is 1. So we have zeros and ones are there. We have the bucket like this is zeros, this is 1. Okay, so what we will do, 1 is 1, we will keep it 1 here, and here it is whatever values are there, we will keep it here. Okay, so it will start from most significant to less significant. So we will keep 1000, then 10, then 100. Okay, so first digit is over. Based on the first digit, least significance to most significant. In base 10, Radix chart would start by the digits in the ones place. So now I did with ones place. After that, tens place. So tens place, whatever tens place. So here we will compare. First, we will make it all the same equal number of digits. Okay, so 1000 is the highest values. 4 digit is there. Then all the numbers will make it 4 digits. So then we know we have to perform this. So second digit after starting this. So after starting this, how it is came? 1000, 10, 100, 1 it is there. Okay. So now 10th digit. From 10th digit we will take. From 10th digit we will take from this right to left. When we are taking this, that 0th place. So then we will keep it at 1, the 0th place. So remaining all are zeros. No? So here 100, then 10, 10,000 is came. Okay, so this is only in all are in 0th, just 10th values. So now 100th value. So 100th value, when we are taking the 100th value, so other than 100, remainings are in the 0th place. So finally 1000 will be there. 4th place we have to check. So it will be ordered. The 1, 10, 100, 1000 it will be arranged. Okay. So it is based on the digits and or letters in the Radix chart is less flexible than other sorting algorithm. Okay. So now this means that for the 3-digit number in base 10, counting sort will be used to sort the first 10th 100th place, resulting in the completely sorted list. So before doing the Radix sort, we have to use counting sort. Okay. So we must know what is counting sort, count sort or counting sort. So if you know the count sort, it will be easy to do the Radix sort. So what we will do, we will take some examples. We will count. Okay. So how we can do the count? Maximum the digits values. What is the digit values? So how many elements are there? That is the number of elements. That is the array. We will take that array. Okay. So example, if 10 elements are there, means we will keep that 10 elements. Okay. So in 10 elements, we will keep how many counts that elements are, how many times it is there. Okay. So for example, we will take that 0, 1, 2, 3, 4, 5, 6, or 6. Okay. So initially we will make it that values available in the array is 1 to 6 you will consider, 0 to 6 you will consider. So example, the given values are 0, 6, 3, 1, 2, 3, 4, then 6, 0, 5, like that. This is the values they are given as this is a given array. You will consider like this. Okay. So after inserting this, we have to count how many values are there. 0. How many count is there? 1. We will update it here. So then 6. 6 will be 1. Initially 1. So when we are counting 3, 3 will be 1. 1. So already 1, also 1. So here 2. 2 is 1 time. So how many times it is present? 3. Already 1 is there. We can press it 2. Then 4. 4 will be 1 time. And 6. Already 1 time is there. Now it's the second time. So now 0. Already 1 time is there. This is second time. Okay. So now 5. 5 is 1 time. Okay. This is counting array. How many values are there? So after that, we have to identify the memory location. Okay, so how we can sort this element? For example, the first zeroth element, first one element. So how many elements are there? So first two elements are 0, 0 values. Okay, so after this array starting from 0 to n minus 1, already we know that if the first location 0 and 1, so two locations are there, no? We will consider this is the 2, initial value 2. So we will make it one more count array. That count array will be increasing this value. We will take that value. It is not array, it is the number of counts. So first 2 is there, no? So first 2 you will keep, then this is the 0th place. From 1 you can start I value. So what you have to do? You will start this value with that is 1th place, whatever value is there, that plus I minus 1 value. So here 1 is there, 1 you will take, 1 plus I minus 1 is 0, that is 2. So now 2 plus 1, 3. So you can update 3. That means only one value is there that will occupy in the third place. Okay, so next to 2. So 2 means 2, how many values are there? 1 value is there, 1, I minus 1 is 1. So 1 plus 1, 1 plus 3, already 3 is there, 1 plus 3, 4. So it will update 4. So that is only one element is there. So next to 3. So 3, how many elements is there? 2 element is there. 2. He already I minus 1, 2. 4 is there. 2 plus 4, 6. So then fourth place. Then fourth place, one element is there. 1 plus 6, 7. So next to 5. Okay, 5 is one element is there. So 7 plus 1, 8. So next to 6, 2 element is there. 8 plus 2, 10. Okay, so you just consider this value. Whenever we can add that value, that position, we can take it from minus 1. Because this is the position. It is not array index. In array index starts from 0, but we are starting with 1, 2, 3. Okay, so now if we will find any values, this location, 10th location, 6 will be there. Okay, 10 minus 1, that is 9. Okay, so 9th place, this what is that? Whenever we read that value 6, that will be kept it into 9th place. Okay, so for example, how we can start this array? This array we are going to start. How we can do? First 0 is there. Okay, so instead of 0, we will start from left side. Then we will start from right side. Why? Because, so if in case 2 element is there, this is the element 6. Then after that, this 6 will come. If you are reading from, so how it will be present? First this 6 will come. Next this 6 will become. Okay. So otherwise, what happen if you are reading from right, left to right? First this 6 will come. Then this 6 will come. Okay, so the order will be changed. Because of that, we will go with reverse side. So first we will start from left. First value 5. Okay, 5 is there. So where the array index 5, so we will take this 5. 5 will be start from 8th position. Okay, you will keep it in the 8th position. So you will keep 5 here. So example, what I am saying, how many elements are there? That many arrays we are creating. Totally 10 elements are there. 3 plus 3 plus 3. So 10 element is there. 3, 4, 5, 6, 7, 8, 9, and 10. 10 elements are there. 0, this index is 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So now you consider. So what I said here, you will take that value 5. So 5, where you can present it? 5, there you will check with this count array. 5 is placed in the 8th location. So 8th location means just we have to, this is the location, but array -1 we have to do. So 7th location we will keep. Okay, so -1, then we will keep that value. Here we will keep 5. So next 0 will be there. Okay, so 0 is which position? 2. 2 minus 1, 1. So first position 1. This 0 will come. Okay. So next 6 is there. This value 6. So taking 6, array of index 6 is 10th position. 10 means -1. So 9th position. We will keep it in 9th position. 6. So next 4. Okay. So 4 means we will take the 4. Array of 4 is 7th location. So 7th means 6 minus 1. So 6. 6th location we will keep 4. So next 3. So 3 have location of 6. So -1. So that means 5. And then 5th location will keep 3. So next 2. In array index 2 means 4th location. 4 minus 1, 3. So third location will keep 2. Okay. So then what is the value? 1 is there in the array. 1 is array 1 is 3. 3 minus 1, 2. So we'll keep 1 here. Okay. So then next value 3. So 3 means you will take a array of 3. Already array of 3 is have 5 values. So 5 minus 1, 4. So 4 means again 3 we will keep. Okay. So now next 6. Here again 6. 6 have already 9. 9 minus 1, 8. So 6 we will keep it in 8th place. So next last 0. 0 means array of index already it is 1. So -1 it is 0th position. So here we will keep 0. So now we will see the elements are sorted. This is counting sort. Okay, count sort or counting sort. So how the count sort is working we discussed now. I hope you understood how the count sort is working. So now if you know the count sort means again based on the count sort only we are going to do the radix sort. Okay. So now we know that how counting sort is worked. Based on that, how the random sort is working. Here, round down of the counting sort algorithm. Assume we have 8 elements. Okay, if you will start elements by the value of the unit place. Unit place means ones place. Okay, ones place, 10th place, 100th place. We are saying no. So we can say that ones place is there is a unit place. So it will then sort the elements based on the value of the 10th position. First unit place we will take, we will sort it. Then 10th place we will take, then we will sort it. Then finally, the process will be repeated until it's reached the least significant locations. Okay. So you just see this example. Let's start with the examples. This is the value. Okay. So initially, this is the value you will take as examples. First 132 is there, 132, 543, 783. So you see this index 783, 63, 749, 898. Okay, so these are the values we are taken. We have to how to do the radix sort we are doing. So first we have to find which is the maximum number. In this given values, 898 maximum values. Okay, so 898 is the maximum value. So how many digits is there in this number? So how we can do that digit value? So modulus of 10 we will take, and then divided by 10 we will take. So we know that sum of the digits, so finally we will get 3. Okay. So 3 digits number, maximum value have 3 digits. So we can make it the 3 digit. This is ones place. This is the tens place. This is the hundreds place. Okay, so why we are doing this? If you know 3 digits means all the numbers will make into the 3 digits. Then wherever we need 0, that we will add the 0. If example 7 is there, we are adding 2 zeros. If 63 is there, we are adding 1 0. So 49 is there, we are adding 1 0. So then there is no changes in the value. So now we will take that first position from this unit place. We have to sort it out. Okay, the first place. So how we can sort it out? So based on that, already it is sorted in the unit place order, because you see here the given number also 2, next 3, then 7, then 8, then 9. It is in the sorted order only. Okay. So how they are doing this? First, we will take this number. First, last place 2 is there. Then first, we'll keep 2. Then 3 is there. Next 3, next 3, next 3. We'll keep that order. Next is 7. Okay. After 7, we can check 8 is there. Then 9, before 9, 8 is there, then we'll keep 8, then we will keep it the 9. So the first step is this particular first place, first array. So you can consider like this array is sorted using the unit place. So after unit place, this is the output. Okay. So the first column is output. So based on this output, we can perform with the 10th place. So here, this diagram is based on the 10th place. How the 10th place is working? Okay. So this is the starter values based on the unit place. Okay, ones place. So now we will discuss about the 10th place. So you see here. So what we have to do initially, how we will keep. So initially we will keep one array. This array indexes on the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that we will create the array. So then we will keep that number in the order, whatever it is there. Okay. So you see that first number 132. So here the 10th place is 3. So then we will keep it that number into 3. 132. The next 4. So 4 means 543. Okay. So next 783. So 8. In 8th place 783. The next 6. 6 place 63. So 063. Next 007. 0th place 7. So here 007. Next to 9th place 898. So here we will write 898. So then 4 is there. Then 4th place already 543 is there. So now we will keep 49. Okay. So 49 is there. Then we have to check now what is the value it is there. So initially as per this array we can keep it that order. Okay. So first 007, 132, next 543, 049, 063, 783, 898. So this particular diagram started with 10th place. Okay. So after starting this, we will go with the 100th place. So again 100th place, same this first array what we prepared now, this array we have to use. So whatever values with 100th place we will keep. 100th place, this is 0th place, 007 we will keep. Next, 1 is there, 132. In the 1th place, we will keep 132. Okay. So, how we will make this once again? So, next, this array will be there. Again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe there 9 values. 6, 5, 4, 3, 2, 1. So here 100th place we will check. First 007 we will keep it here. Next 1 place 132. So next 5 place 543. So 543 means here we will keep 543. Next 049. 49 we will keep there. Then after that 063 we will keep 63. Then 783. So in this place 783. Next 898. So now we can print the final answer 7, 49, 63, 132, 543, 783, 89. So the last array with 3 digits, no, this is a final sorted array. Okay. So like that we can do that radix sort. So find the array largest element. First step by step we will see that how it is working. So we have to find the largest element. Consider A to be the number of digits in the maximum. Okay, so here in the previous example, 3, that number of digits is 3. So now A equal to 3 you can consider. A is calculated because we must traverse all the significant location of the elements. The largest number of these are 898. Whatever I said, we will take. So it's have the 3 digits. So now A is equal to 3. As a result, the loop should be extended a hundreds of the place 3 times. Okay, once unit and 10th place and 100th place. 3 times we can implement the loop. Okay, so here 3 times we are executing. Sort the digits of each significant place with any stable sorting techniques. You must use counting sort for this. So already we are explained how the counting sort is working. Start the element using unit place digit 0. Okay, so A equal to 0 means first position, 0th location, then 10th location, then 100th location. Okay. So for example, they are given the values 2, 3, 3, 3, 7, 9, 8. Okay. So how it is identified this array? You take it that value initially, how many values are there? Okay. You will take count equal to 2. If 2 is there in the array, so for array of index, count of index 2 is equal to one number. One time it is there. Okay. So now 3 is there. Okay. So what they are doing here based on this values they are taken. So see here, this is the unit place 1. So 2, 3, 3, 3, 7, 8, 9. Okay, based on this value we are executing now. So we are taken that last digits. Based on that we will make it the count value. So how the count value will be there? Just see there. For 2, one time it is there. 3, how many times are there? 2 times. Okay. Okay. So there is uh, 3. How many times? Actually 1, 2, 3. 3 times will be there. Okay. So here counting start. Already we discussed how to do that. For counting sort, here small mistake is there. How they prepared? Like we have the doubt. 2, 3, 4, 5 also is there. Okay. So based on this count, we are making this one. So the final output is the same. 2 will be there. Next 3, 3 will be there. Then next 7 is there. Only we are exchanging these two values. Okay, 8, 9. So for given values 132, 543, 783, 63, 7 will be the same position. Then only we are exchanging 0, 49 and 898 because this is the first place we are compared. So next place we are compared with the 10th place. After using the counting algorithm, we will keep first 0, next 3, next 4, next 6, 8, 9. Okay, after changing that 10th place, we will go for 100th place. So first 0 will be there, then 1 will be there, then 5 will be there, then 7, then 8. So final, after doing this operation, all the elements are sorted. So time complexity. So it is not in place comparison algorithm. So how much time it will take in case worst case means we are compared with all the elements. Okay, with so how we can say this in case same number of digits except one. Okay, when all elements have the same number of digits except one, which has a significantly large number of digits. So what we will do, for example, 100, 999, 80, 88, so 120. So like that, we will take all the numbers of 3 digits. Example, only one number is in 8 is there. It's only one digit. we have like this, what we will do? For only one digits, we can do this all the operation. Unit place we have to do, tenth place we have to do, then hundredth place we can do. Otherwise, what we will do? If all are 3 digits means simply we can do with last positions only. Okay. So this is the worst case. Next, when all the elements have the same number of digits, the best case scenario occurs. Okay. The best case means all the numbers are same digits. If we don't have 8, these numbers only means what we will do? We will do this with the last digits only. This digit only we can sort it. Okay. So it may be order of A, n plus B, the best case complexity. If B equals, then order of n, the time complexity is order of A plus n. So here A is number of digits, n is the number of elements in the array. Okay. So how many digits is there and how many times we are working for sorting it. So that will be considered as a B array. So in case average case, what is the average case? So you consider the distribution of the number of digits in the average case. There are p passes and each digits have up to d different values. Okay, so example, 5 digits number is there. 5 numbers are there. This 5 digit number, 5 numbers, all the numbers have individual digits. 7, 11, 128, 2000 and 5000. Okay, example, 50,000. We'll take like this. So all the elements are different cases. Okay, but in this situation, we will go for average cases. Okay, so it's a different digits are there. Each digits have different digits. So this will be based on average cases. In the average cases, we can consider order of p into n plus d. Okay. The next is space complexity. Space complexity for radix sort is it implies counting sort which uses auxiliary array of size n and k. So we have to create counting array separately. Based on the counting array, we will do this temporary array. So this array according to k values, because 0 to 9 the elements are there, and k value, this is n elements, the number of elements total. So this is how separate array, this is how separate array. So n plus k we are using for space complexity. So now we will discuss about advantage of radix sort. What is advantages? Fast when the keys are short, when the array elements range is small. Okay. So the element ranges are very small. If in case only 3 digits, means if even 3 digits means 999. So whatever values are there, then we can do this fast. Used in suffix array construction algorithm, such as Manpur's and DC3 algorithm. So we will remind this Manpur's and DC3 algorithm. These algorithms, it is using the radix sort techniques. Radix sort is a stable sort because maintain the relative order of elements with equal values. So these are the advantages. What is the disadvantage? It's a less flexible. Okay. So why we are saying less flexible? Because it is based on the digits or letters only. That's why we are saying it is less flexible. As a result, for each different type of data, it must be rewritten. Okay. So how we can do that? Accordingly, we will rewrite it. Okay. So if in case 1000 4 digits numbers are input, means we can rewrite the entire program. Okay. So if 100 digits means, again you can do this according to that. Radix sort has a higher constant than sorting algorithms. It takes up more space than quicksort, which is used for infinite sorting. Okay. So quicksort is faster as well as complexity, space complexity also less. Compared with that, it is occupying more space. So Radix sort may be slower when compared with quicksort and merge sort. It is slower only because it will compare all the elements with the digits. It is taking more time. So operation includes sub insert list and delete functions as well as the process of isolating the desired digits. So if you want to insert the element, in case all the elements are 3 digits, suddenly you are inserting the 4-digit number 4583. If you are inserting this number, then it will be the problem to change the programs also. Okay. Okay. So where we are using the Radix sort, there are some applications are there. So especially it is used in typical computers, a sequential random access machine, multiple field key records. Okay, so there we are using the Radix sort. While creating a suffix array, use DC3 algorithm. So already we seen that DC3 algorithm also it is used. Radix sort algorithm locates location where there are numbers or extensive ranges. Okay, so based on the radix, it will be stored. So now we will see this program wise how it is there working. So initially we know we have to include the header files. We are using STD standard input output CONIVO for console input output and standard library input. So these are the files we are included. So I said we have to find the maximum number in the given array. So then only we know how many digits it's have. So for that we are using to this particular function. What is the function name? Max value, and we are getting the array and the integer as array value, a number of elements in the array. We are getting that. After getting this two value, we will take initially maximum value will fix as the array of 0. That's the first value we will take. We will fix as maximum. Then we will check with the next value, it is greater or not. If it is greater, we have to fix maximum value, return maximum. So using this function, we have to find the maximum number of the given array. Okay. So I hope you understood how it is working. Now Radix sort algorithm will take. So how it will be work. Okay. So first we have to find the max value of array. So largest element we will take, that is the element it will take here. Then resultant array, how many we have to create one array with that n value. So now we have to check while largest element divided by digit place is greater than 0. So example, if 3-digit number is there, 185 is there. Okay, this is a 3-digit number. So divided by digit place, initially digit place is 1. We are fixing 1. 1. So equally, what is the value? If you are dividing it, only 185 we are getting. 185 is greater than 0, it is true. Okay, so if it is true means initially you have to create one array, initialize with 0. So if you are given one value, what is the meaning? We'll create a count array. So we are given the maximum size is 10. We can declare like this means initially garbage values are there. If you are initialized any values, if I will give only initialized one value, the remaining value also initialized with 0. Okay. Then we have to do that count array. So each value we have to find initially how many numbers are there. Okay, so we'll take that array value. So count array of indexes. In index we will take. So what we will do? We are created one count array. This array have indexes starting from 0 to, so whatever values n minus 1 it is there. Okay. So example 0 to 9 we will keep 0, 1, 2, 3, 4 up to 9 it is there. Okay. So what we have to do? Count the key or digits in counter. So first what we have to do? Array of I. Array of I means array of 0. We will take the first value divided by digit place is 1. So for the first place, whatever after dividing by 1, modulus 10 we will take. Modulus 10 means the first digit we will take it. Okay. So in case 185 is there means 180 modulus 10. What is the value? 5. So 5 you will take count of 5 plus plus. So what is the count of 5? Here already count of 5 0 is there. Okay, this is the fifth place. So here count plus plus means 1, it will increase. Then the loop will be incremented by 1. So I equal to 1. So now it will come array of 1. That second value will take digit plus 1, the same value modulus 10. If you are calculating the remainder, you will get the second value, whatever value is there, you will keep 1. So it will increment 1 by 1, 1 by 1, 1 by 1. The same value if you are getting that, accordingly the count array will be append. Okay. So example you will take, this is the array. So what is the array? 1, 2, 3, 1, 2, 3. Example you will take. Okay. So I have to create the array, count array 0 to 9. Example, we have the digits may be 9 up to 9. Okay. So here 0, 1, 2, 3, 4. So it may be like this. So then how the count array is working? Array of 0, 1. It will take 1. 1 by 1, 1. 1 modulus 10, 1. So 1 ko 1. Then it will be incremented now, count plus plus. Already it is 0. So now it is 1. So next I will increment it. Second value, array of 2. It will take the 2. So 2 modulus 10 is 2 only. So 2 will take 1. So next count value incremented here. Already 0 is there. Now it is 1. So now 3. So example 3. Okay, 3 is there. So 3 modulus 10, 3 only. So 3 already 0 is there. Now it is 1. So now again 1 is there. Okay, so here this 1 if you are taking, what happened? Again 1 modulus 10, 1. 1 is already 1 is there. 1 plus 1, 2. So count plus plus 2. So here second number 2. Third number 2. So it is all the values are, this is the count array. Okay, so 1 have 2 values, 2 have 2 values, 3 have 2 times. Okay, so this is we are identifying. So after that, in the count array I said no, we have to create another array. So again we have to start with initially it is 0. So 0 plus 0, then next place 2, then 2 plus 2 4, then 4 plus 2 6, then remaining are 6 plus 0 0 0 0 0. So here first 6 minus 1 5, fifth place we will keep that value 3. Then 4 minus 1, third place we will keep. Here 2 minus 1, first place we will keep. Like that. If you are keeping that, it will be sorted. Okay. This is second count array. Okay. Here one we are using one for loop for counting the values. Second one is for, it will allocate the memory allocation. How we can do that? Count plus. Why we are using count I minus 1? So what is the meaning of that? Count array of I equal to count array of I plus count array of minus 1, previous value. Okay, previous value will take. So current value plus previous value will take, then we have to add it. That we will print it into the count array of I, that value. So after changing this, again I said we will start from the last value. Okay, we have to place in the particular position, last value is greater than 0 will take, if I minus minus. Okay, so again this is a resultant array. This resultant array I said no. So if from the last value will take, okay, last value is 3. 3 will be fifth position. Next 2 in the fourth position. Next 1 in the first position. Like that we will do. So that's why this resultant array of index. What index? Count array of that modulus I. Array of I divided by digit place modulus 10. Whatever value we have calculated previously, that value minus 1. Okay. So in this place, okay, resultant array with that count array value, whatever value is there, array of I is there. That will be assigned to that. Okay. So count array minus minus. After adding to the resultant array, we have to minus minus we have to do. Or we can write like this also, minus minus of resultant array. If we are doing like this also, it is correct. Okay. So why? Because if already one value I kept it in the fourth place. Okay, 3 over. Then this minus minus means count array. This value will be 2. Okay, so 3 already we keep 3 times. So 2 times is there no, fourth place over means next third place be there. So for that purpose we are using minus minus. So after adding this, we have to print that value. So what print? Before printing that, digit place we have to go for. First ones place we are doing. So now 10th place we are going. Okay. So next the while loop will increment. So 10th place. Again if multiply with 10 means, again it will go for 100th place. Then 1000th place. Okay. So accordingly this is for resultant array printing based on the first digit. Then we will multiply with 10, 10th place, then again it will print 10th place order. So then 100th place, like that it will execute while loop. So finally the elements are sorted. Okay. So for display, we can use simply printf statement. Then initially we have to find, given the values, it's how 100 have the 3 digits. So here it will take as the 3 digit, or number of elements n is 3. We can pass that array 1 with n value. N is size of the array. Okay. Number of elements. So Radix that we are calling the function with the array 1, then number of elements. Then we are calling, we just print the display. So this is a program for using Radix. So these are the table whatever we are discussed in the previous lectures. We are discussed about bubble chart, and then selection chart, insertion chart, cell chart. Finally, we are discussed about the Radix chart. So these are all we are already discussed about the time complexity. What is the best case? What is the average case? What is the worst case? We already know that. For our comparison purpose, I kept it here. So finally, space complexity also for all the in-place algorithm, it is using order of 1. Then only Radix sort is used for n plus k. So k is the number of digits. Okay, based on the number of digits only the space will be occupied. So here only cell chart don't have the stable, but remaining all the algorithms are stable algorithm. So now it's a reflection spot. You see this Radix chart has average case, time complexity is. So previous slide and previously we have discussed about the average case. What is the answer? I'll give 10 seconds time. You will write it. If your answer is correct, we can proceed further. Otherwise, we will go back and watch the video once again. Then you have to answer it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Hope you are written in your notebook. You just compare the result. So if your answer is correct, order of p into n plus d. If your answer is correct, you can proceed further. Otherwise, go back and watch the video once again. So we are discussed about the Radix chart. What is Radix chart? How it is working? Then bucket sort and counting sort. How it is useful for Radix chart? Those things we are discussed on the introduction. And explanation with examples. We will take some examples. We discussed how it is sorting. Then finally program for Radix chart. So we are discussed with the Radix chart program step by step. So I hope you understood this how it is working. So you try to write the C program to get n numbers. You will take the n numbers as an input value and start the values based on the Radix chart. You can check with best case and average case and worst case. So what are the best case? Best case means all the numbers are in the same digits. The number of digits are same. Okay. So if you are taken 3-digit is common means you can take all the numbers are 3-digit. Worst case means you will take like what is the worst case? Worst case means all the numbers have different digits. 1, 10, 121, 250, sorry, 2521, something. It will take different digits. Average case is all the numbers are same digit, only one number or two numbers have different digits. So example, 3-digit number 101, 102, 105, like that. So here you will give 8. If you are given this average case. So you will check as input in different inputs and how the Radix chart is working. So finally, having completed this discussion on Radix chart, now students should be able to develop a C program to sort the elements using Radix chart. Now you know how to write the program for Radix chart. If whatever number you will give, that chart how it is working also you know. So further doubt, you can refer the textbook like classic data structure, which is authored by Devasis Samantha, as well as we can refer data structure using C, which is authored by Rima Thareja. Thank you all for listening this video. If further doubt anything is there, you can refer the tutorial sheet as well as will come with the doubt for discussion in the classroom. Thank you all.